All right, guys, so for those of you who are here, go ahead and click on that link in the Zoom chat. That should let you take a look at the presentation on your own. So that way you could go ahead and just see all the stuff. If you can't see it from my screen, then you can see it from yours. Anyways, make sure you use your student email if you're going to try to view the presentation, because it doesn't accept anything that's not sjsu.edu. Okay, now we could start. So we're going to be covering a couple of topics that will very likely show up on the final, and that's going to be comparable and inheritance. So we're going to be starting off with a conceptual review of comparable. We're not going to go too much into detail about the coding because the last few SI sessions have been all about that, and we have also covered it in class quite extensively. Inheritance is something that we're going to deeply cover for today's virtual session. And if this is your first time at a virtual session, the way it pretty much goes is that Yen and I are going to be doing these activities on our own, at our own pace. And it's recommended that you go ahead and try to do it as we go about it and see if you can keep up. And that way, you know you're practicing it rather than just watching us passively. So that's recommended. But if you're just listening in at work or something, then if you're just watching the video, then you could just pretty much see how it goes if you're lost. Another thing is that you can still use the chat to ask questions. So if there's something that confuses you that Yen and I does that doesn't make sense, feel free to ask at any time. And then when Yen and I see a chance, we will address your question as soon as possible. So that's pretty much about it for logistics. We can go ahead and start onto this. So the very first thing is we're going to be going over comparable do's and don'ts. So I guess we could start with the incorrect things to do. So Yen, do you want to go over the first one? So this one is talking about using primitive types that calls on compareTo. So what does this exactly mean?
So we'll start with the incorrect first, right?
Mm-hmm.
Okay, so primitive types calling on compareTo, what that means is if you take a look on the slide, in one, what data type is it? It's an int, right?
Mm-hmm.
So an int is a number, in other words. So can a number call on a method? That's what it means. But a number cannot call on a method. Only objects can. So this wouldn't work because you cannot say 55 dot compare to 56. That's what the behind the scene look like. But to fix this, you can use a string object, which is, let's say, string name. So name dot compare to. Mark, can you type that along the slide?
Or do you want me to write in the code actually?
Sure.
Okay, I'll go ahead and try to do it quickly. So let's call it test. And then I'll say implements comparable. I typed it correctly, right? Okay. And then did I spell that right? No, I did not. Like that.
Object, the parameter.
Yeah.
Right.
Now I'm just going to say return 1. So it's going to be string name. So I guess I should have named the student, but not here. I'm going to say public name, not name, test is going to take in a parameter, and it's going to be string the name, and I'm going to have it over here. I'm going to say name equals the name. So it's pretty much what everyone's used to when it comes to this.
You should do private string name. Okay. So to fix the incorrect way, you can use name in this case. So let's say, so let's just cast it first.
I'm just going to do this real quick.
Do you have a student class in the project?
No, I don't.
Okay, let's assume that we do. Okay. So let's just cast a student real quick so it makes more sense.
Okay. Well, I could just cast it into test. That's what I can do. So I'm going to say it's going to be of type test, and then I'm going to say other. And the important part here is that when I cast it, okay, so this is actually part of this first correct thing to do for comparables. You have to make sure you cast first. And so whatever type this is supposed to be the same type as whatever the class is that you're on for compareTo. So I'm going to be using test other, and then I have to cast it into a class. And then I'm just going to be using other object right there. And that's how I do the casting.
All right. So let's do the next line. Let's just compare first by ID, then by name.
Mm-hmm.
So
you wanted to show this, right?
Yes.
Okay. So if I try to compare this, so ID is an integer, and I use compareTo, and then I do it on the other's ID. So other dot, well, actually I have a get ID, so actually.
You could do that. You can do just that.
Oh, okay, sure. Why not then? Yeah, so it would throw an error.
So you can see the error. So this is a compiler error. So int cannot be dereferenced. What it means is that a number cannot call on a method, right? So when you see an int or any number type like a double, for double you can use the one that we were introduced in the class, which is double.compare, and then double one or double two. And with int, look at the correct way, we can use subtraction. In this case, n1 minus n2, so we can change it up to here with ID number.
So pretty much instead of saying integer 1 dot compare integer 2, what I should be saying is return integer 1, which is in this case ID, minus other dot ID, because these are both integers, and that would work fine. Now here's the weird part. Why does this work, Yen? So a lot of students would get confused when they see this. They're like, this minus this. Well, why are we returning that? Shouldn't it return 1, -1, or 0? What does this do?
Okay, so ID refer to this dot ID, and order refer to order dot ID, right? So can you go to the PowerPoint real quick?
Mm-hmm.
And can you do the 3 operator sign, the less than, greater than, and equal? Somewhere, right? Somewhere.
Where do I put it?
Anywhere you find space.
Okay.
So,
right, so there's a little, well, that's really small, so let me just make it large. So here's the less than sign, here's the greater than sign, greater than equal to, lesser than equal to. And
no, just less than, greater than, or equal.
Okay.
Okay. So can you flip this and that for the first one? So this less than that, this less than other. Okay. So if you look at this expression, this dot ID less than that, I mean other dot ID. So if this number is less than the other number, that means this number will go before the other number. And if you subtract this number with other number, let's say you have like a 3 for this, and other you have a 5. So 3 minus 5, you get -2. So -2, that means this is actually less than the other. So -2 means before. So that concludes that this goes before the other. So goes the same logic for greater than. So if this is 5, but other now is 3, this minus this is 5 minus 3 as other, you get 2. So if 2, then you get a positive number. So that means this goes after the other. But if when you subtract them and you get 0, 0, that means they equal. So the subtraction works in this case, in which it tells you is this object, or I mean this number goes before, after, or they equal. So if they equal, we have to consider another case, which is in this case we compare by name.
Yeah. So let's just try that in our heads real quick. So for example, if I said this is 1 and the other, so this equals 1 and then other equals 10, this should go first. That means compareTo should return a negative number. 1 minus 10 is -9. It doesn't have to be -1. It could just be any negative number at all. So 1 minus 10 returns a negative number, and so it works. All right, let's try for an equal. 10 minus 10, well, they're both the same, and so it returns 0, so it returns that they're equal. 12 minus 10, we should be going after, so this should be going after other. So 12 minus 10, that would return a positive number. It doesn't have to be 1, it can be any positive number. So 12 minus 10 is 2, and so it puts it after the 10. So that's how compareTo would work for integers. So that's the little neat trick.
Okay, so can you comment out the ID part? And now let's do name.
Okay.
So in the case, the integers are the same. When you subtract them, you get 0. Then there should be another case for you to sort them out, right? So the other case that we look into is the string. So string name. So string is an object of string type. So in order to use compare strings, we have to use compareTo. So go ahead and copy and paste that.
Well, I could just, okay, I guess I'll write it. So then this would just be name, and the other one would be other.name.
So Mark, where does compareTo comes from?
So to my knowledge of it, calling on compareTo is like calling on the native compareTo that Java already provides for you, in a sense. So it's not really calling on your compareTo. What it's actually doing is calling on Java's compareTo. Let's just say, you don't have to think about it too much. You just need to trust Java that they say, okay, for strings, we can do it for you. Just call in this method, and it'll do all the rest. So you would just put in a string over here, whatever is the string that you're comparing. In this case, it's our name, right? And then you have the other person's name, and then you just go .compareTo. So you're not the one writing this this particular compareTo. This outer compareTo is the only one you're writing, but that little inner one is the one provided by Java. So that's what you would do with strings.
To be more specific, Mark, can you go search for string API Java? if you go down, you will see a compareTo method.
I'm gonna use this. Okay.
Yeah, so there you go. So that is where the compareTo comes from. And string is an object, so an object is legal to call on a method. And that method, like Mark said, is already provided by the Java library.
Yeah. So they wrote it for you, so you have to do less work, which is always good, which is always handy. So why is it that a string is allowed to say compareTo, but not a number again? Just in case if people forgot.
So again, string is an object type. So, and there is a compareTo method within its class for you to use to compare this object and the other object characteristic.
Yeah.
But for int, it's a number. It will return you a number, and a number cannot call on a method.
Mm-hmm.
Vice versa for a double is also a number. But so because of that, for int, you can use subtraction, and for double, you can use a double.compare. It's not a method from the double class.
Yeah. So let's say I turn this into a double, and I want to compare by the IDs again, even though they're a double now. I could just take this over here, this beautiful line of code, and I could put it right here. So Yen, you said numbers can't use methods, but why am I able to say double.compare double one and double two? In this case, it would be ID and other.id.
So double is a class reserved for doubles. So if you go search for API and notice that the letter D is capitalized, which signify a class. And this class is a static class. So when you go into that class, there are a bunch of utility methods for you to use. And most of them, I believe, fulfill the conversion for you. So in this case, you can use a double for that to compare. And if you go down, there's actually, see, there's a compare method, double one and double D2. So that is for you to compare them. And in the end, when it finished comparing, it will return an int. And that int is what you want. So either a positive, a negative, or a 0.
Yeah. And so for those of you who are still kind of confused, why is a double able to use .compare? Notice that it's not compareTo, it's compare. And integers are not doing that. And if you're wondering why is a double able to call a method, well, it's actually not the double primitive type. This double library over here is actually a wrapper class for that primitive data type. So think of it like you have the double, and then you have a class surrounding that double. And so that's what this is all about. And so that's why that's happening. Okay, so that's enough for the correct ways to do it. Let me just delete this.
And let's look at the next incorrect way.
Mm-hmm.
So implementing the compareTo interface, implementing comparable interface yourself. So what that means is, can you go to the project and create an interface comparable?
It should be. All right. So a lot of students have the tendency to go ahead and just, when they see that they say, implement the comparable interface. All you really have to do is just this. But for some reason, students have a tendency to automatically go over here, go to interface, create a new interface, call it comparable, and then they would go here, and then they would try to implement the compareTo method. So they'll just say compareTo, and then I guess you would put an object and then other.
notice that it does compile, but it will not work. So why doesn't it work? So Mark, can you go searching for API comparable?
All right. It's already right here.
All right. So notice that comparable is already an interface existing in the Java library that is already made for you. So that is why you don't need to rewrite it. Because if you do rewrite it, you will not be able to use arrays that sort or collections that sort, because those classes, they are embedded, they are both implementing comparable of the Java library one. But this comparable, if you create in your object, this is just for you. And when you try to run the Java code and calling arrays that sort, it doesn't know which comparable are you referring to. Are you referring to the library one, or are you referring to your custom-made one? And since it works locally first, it will go to your comparable too. And this comparable interface is not connecting to arrays or collections classes. So it will not sort whatever you wanted to sort.
Yeah. So if Java's already given it to you, then make sure you don't try to do it on your own. Yeah. In fact, it would actually make it harder for yourself. So
yeah, we only make new interface if it's not already in the library and it is unique to whatever your project is.
Mm-hmm. And this will be true for even your future classes where you start using other types of interfaces. So definitely be careful about that. Are we done with comparables yet?
There's one more, the
right
parameter type.
here.
You want to go over that one?
Yeah, sure. Okay. So we have right here. Notice that says student right here. I'm gonna underline it. Actually, no, I'm gonna highlight it right there. Notice how it says student. That is actually not a good thing to do. Now, the reason why is because when the Java writers wrote this code, they said, okay, when people use this, it's going to be for any object at all. Like it can be for a test class, it can be for a student, it can be for a bank account. And if we said that this was specifically a student, or in this case, if we said it was a test, then sure, it can theoretically work, like design-wise, for the test class. It could. But the problem with that is, what about the other classes? If they implement comparable and it starts off as a test class, you can't really cast a test class into anything else. You can't really go from a test to a bird, or a test into a student, or a test into a bank account, or a test into anything else, really. Object, however, object is this universal class that every single class comes from. So that's the idea behind it, because everything inherits from object. Because everything that's a class is an object. We're allowed to cast it into anything else. That's why you're supposed to label this as object. Now, there's workarounds to this that you learn in other classes, but for the sake of this class, we're going to keep it simple and just go with this route. And that is just to use object as a type for your parameter and to cast it right here. So that's pretty much about it. Did I miss anything?
No, that's good.
Okay. All right. So just reminding you guys, if you have questions or we're going too fast, feel free to say something in the chat. Otherwise, we're going to keep going. Okay. So now we're going to do a little bit of coding. So, well, I say a little bit, but okay. So we're going to work with inheritance. So the idea here is to get everyone familiar with how inheritance works. So we covered it a little bit in class, but there's a few things that can catch students off guard, especially when it comes to the API and the syntax. Rather, it's mostly the syntax. So we're gonna start off by creating a struggling student class. So like we're all broke college students. We're all struggling. So yeah, we're gonna make a struggling student class. So wait, whoops, I should rename that. Right. Struggling student. All right. Now I can open up this and I can go here. So it's going to have an instance variable called money, so nothing too fancy. So it's going to be private double money. And why is it good to make money a double, Yen?
So again, money is, there's dollar and there is cents. So just to be specific, we do that so we can include a decimal point.
Right. Then it's going to take in a parameter that's a double, and it's going to be, I'm just going to call it money, spice it up. I'm going to use this dot. So this dot money equals money. If you still don't know this, by the way, this is just saying this dot money is referring to this class's money, and then this other money comes in from whatever the programmer wrote. So that's pretty much it. Then it has two methods. So it has a method called can afford. So the point of this can afford method is to tell you true or false if this student can afford money, or some sort of
Boolean.
Yeah, so it should return a Boolean. Yep. Does it need any parameters, Yen, if it's returning a Boolean?
No.
Okay. So I can say right here in the instructions, it says if the student has more than 300, no, not 300, 3,000 money. I say money because it can be any currency, right? Like I could have said dollars, but you know, it could have been any currency. So I just went with money. So a student can write this. If, actually, we'll start with this. Boolean equals false. Then we say if, wait, I need a name. I'll just call it bool. If, whoops, I already wrote that. Money, so it says has more than, so it has to be greater than without including the equal to. So it's going to be 3,000, like that. Then I'm going to say bool equals true. And then I just say return bool. So does this work, Yen?
Mm-hmm.
Is there a faster way, though?
Yeah, another faster way is you don't even need the Boolean bool. Or the faster way is just return money greater than 3,000.
Yeah, so
just comment that out.
Yeah, well, okay. Yeah, I could just, yeah, sure. Okay. Edit, comment. There you go. For those of you who don't know, you can do that. You can do that. So if you wanted to save time, especially for the final exam, you could just write this right away. If this condition is true, it returns true. If this condition is false, it returns false. So
and why? And it's working because money greater than 3,000 is a statement that either returns a true or a false. So that will work in any case.
So if you look at it like this, it'll be like, how are we returning a sentence, right? Or like a little statement. Well, yeah, if you put in parentheses like this and look at it this way, like whatever is the condition left by this, that is the value I'm returning. That's what it's saying. So if this condition's met and it's true, then it returns true. Otherwise, false. So it just does it.
Yeah, that is two ways that you can do it. And let's do a getter for
the money.
Struggling student, yeah.
Okay, so it has a get money. So
double.
So it would return a double, and it would be called get money. and it would just return the money. Right, simple enough.
Yeah. And this is all you need for this class.
Mm-hmm.
So this is the parent class. So let's go ahead and create this is the subject class. So let's create the subclass. So a student.
Okay. So now there's some of us are fortunate enough to receive enough financial aid, or some of us have that one really rich uncle that is always super nice to us and loves us very much. So we'll have an aided student class. So that is what it's for. Now, okay. So what's the difference between trying to implement a inheritance in comparison to an interface? And what do I have to write over here?
Okay. So one of the difference between interface and inheritance is the keyword that specify them. So for interface, you have implements, but for inheritance, you need to say extends.
So I'm going to say extends.
Struggling student.
So
for interface, you can implement as many interfaces as you want, as long as you implementing the methods that you get from those interfaces. But for inheritance, when you extend, you only extend one class. Mm-hmm. And you will inherit whatever there is from that separate class. So let's go ahead and create the extra instant variable.
All right. So now we have an extra instance variable called 8. So it's going to be also a double because it's still technically money. So I'm going to have private double 8. And I'm going to make the constructor right here. And I'm going to say public aided student. So it's going to be like your normal class, right? Like we could pretend this doesn't exist over here for now. And we can just do this. And over here, we can have a double.
Money and a double A.
And then aid. So for this one, it's asking for two things. It's going to ask for money and aid because we're an aided student. So we're struggling. We're technically a struggling student, but we're also receiving aid. So there's multiple ways I can approach this. So there's a lot. This is where plenty of students get stuck. So I see money over here. So shouldn't that mean I write money like this over here? Is that what I'm supposed to do, Yan? Or is that not a good idea?
That is not a good idea because when you extend struggling student, if you look into struggling student, you already see a private double money. And since aided student is a subclass of struggling student, it means that this class already inherit whatever there is from the struggling student. So there is no need to rewrite private double money. It might or might not work, but it would definitely make your compiler confused into which money are you referring to. So I would just use the keyword supper to call money.
Okay. So this is the nice thing about inheritance. When something is already possessed by your parent, then you get it too. You know, like think of it like a hand-me-down from your parents. They have it, you have it. Anything they have, you have it. And then you can have more, or you can then change it up a little bit, but you know, what's theirs is yours now. Okay, so and the way you do that is through the word super. So you can say super. Okay, so when I say super like this, right? What happens here is the compiler goes like, okay, I see the word super. So I'm going to replace that with whatever I'm extending. In this case, it's struggling student. So I go to struggling student, right? And I'm like, okay, are they calling a method or are they calling a constructor? Well, it's the name followed by a parameter. So it's probably the constructor. So it goes here. And what we can do is we put in money, right? And so that would work. So I put in money. So I take in the money that, okay. So let me slow down a bit actually. So let's say I'm the aided student and I'm getting money. So then I pass it to my dad, which is struggling student. And I say, okay, dad, here's the money. And he's like, okay, here, I have your money now. Now it's our money together, or something like that. But the point is, what's theirs is yours, and so you pass it along, and it's handled by the parent class or the super class, rather. So that's pretty much what happens. Okay, so now we have aid. So our dad, our special dad that we love so much, has already handled money. Now we just got to handle aid on our own. So our dad doesn't have the aid, unfortunately, but we do. So we can use aid equals, well, actually, no, this dot aid equals aid. So why can't I say super aid again? So why can't I say like this, like super money aid? Why can't I just like erase the other two lines and just use that?
Okay. So because when you use the keyword super, that means you had to go back into the super class, struggling student. So go ahead and go in struggling student.
Mhm.
But notice here, only when you look into private instance variables and the constructor, you notice only this money or money is available. There is no A. So when you call the keyword super money A, there is no A from the super class to find. So it will give you an error. So only money in this case would work, as Mark said. So now you go back to, let's say go back to the A student. And now you notice in the subclass, there is A as the private instant variable. Oh, so this is the extra instant variable that you have for this class. So you have to initialize that in the next line.
Yeah.
And also when you use any instant variable that is also from the superclass, make sure you do that the first thing, as in super money in this case. And then you initialize whatever from the current subclass that you're trying to write.
Yeah. So in a general sense, if I added more things like I don't know, like it can be anything, and added more parameters to my constructor, then the parent class can't really handle that because they don't have anything like that. Think of it this way, like our parents are getting too old, they can't get used to the new stuff that we're doing, right? So you can think of it that way. All right. So the next thing is, instead of just adding an extra instance variable, we have a can afford method that we can change up. So right now, technically the aided student has the get money and can afford method, right? Yes or no? Yeah.
Yes.
Yeah. So so is there a problem with our can afford method right now, Yan?
So right now, for this new class, we have the new instant variable that we have to take into consideration in to see if can afford could change the value of true or false. So in this case, we had to change can afford a bit and incorporate A somehow into that method. And so we will have to override that can afford method, because when you go back to the superclass, the superclass doesn't have any A in that method. But we want to change that in the aided student class. So that is what you want to override.
So yeah, basically we have this aid and we're not really using it if we use our parents' can't afford method right here. So all they do is they look at money and they look if it's greater than 3,000. But we have an aid. We should be using it. So it should have been something like can well boolean public boolean can afford, and then it should be like this. So when I write this again, does it make an extra can afford method again, or does it replace the old one?
It will replace the old one because recall from inheritance, there are 3 types of methods. First one is inherit, next one is new methods, and next one is override methods. For inherits, for override is a variation of inherits because it's basically inherit whatever from the superclass, right?
Mm-hmm.
But for override, you inherit the method name and return type and etc. But you want to change the middle part, something in the middle that the superclass have, but doesn't have in the current subclass. So take a look at that way. So now you go to A class. There is, the A is student class. You need to take A into consideration. So it's most likely something extra from the parent, right?
Mm-hmm.
So let's just use this shortcut. So can you copy and paste money greater than 3,000?
Okay.
So you go over here. And now how do you incorporate A into that mark?
Well, we should always be looking at the combined weight of our money and aid. So it should be something like this. But does this work?
I would do super.
Mm-hmm.
So you cannot use money literally because money is a private instant variable. But when you look into struggling student class, you see a getter, which is a public option. So you can use super dot get money, and it will get the value of the instant variable for you. So that is why it's very necessary to create getters for the parent class, because you cannot retrieve private instant variables value, but you can definitely call its method to get out the values of those instant variables.
Mm-hmm. Am I allowed to say this though as well? So can I say super dot money?
I don't think so. Yeah, because again, money refers to private instant variable, and the keyword private specify that only that class can have access to. But public from get money allows you, the subclass, to get the value of that instant variable.
Question. If I get rid of super dot like this, would it still work? I mean, it seems to compile.
I would say yes, but I would still do the keyword super
For clarity?
for clarity.
Yeah.
Just because in case you might have another method called get money or whatever, so, or you might want to rewrite get money, then it will be creates confusion. Which get money are you referring to? Are you referring to get money from aided student, or are you referring A, get money from struggling student? So I would just use super dot get money just for better understanding.
Okay. So I think that sums up for this exercise for inheritance.
Yeah.
Is there anything you want to add on to this, Yen?
Okay, so I will summarize it a bit. So notice in here in this class, you don't see it, but there is two kinds of methods happening right here. One is inherit method, which is get money, and the other is override method, which is can afford. And notice can afford is from a struggling student, and it does know where that is coming from. It comes from the parent. And then you override the method itself. So it will satisfy the condition for aided student. Inherit is somewhere here, is somewhere in aided student class, but you just don't see it unless you call it. But the only thing that we're missing right now is new methods. So maybe let's create a getter for aid as a new method.
As a new method?
Yeah.
Okay. So we'll say, I mean, I'll just do this.
Get aid though.
Oh, get aid. Oh, I am so I am so out of it. Right. I didn't hear you properly, so all right.
So now this will satisfy three kinds of methods. Get aid would be your new method. Get can afford would be your override method, and get money, which you don't see but imply, is also right here. So Mark, can you explain why the difference between interface, like and inheritance? Why in this case do we have to use inheritance but not interface?
There's a lot of similarities, but do you just mean like the difference between can do and is?
Yeah.
Okay. Okay. So if you think about it, there some ways are just easier if you just define them as as a descendant of another thing. So if you're modeling animals, for example, you can say everything's an animal, but then there's mammals, and then there's reptiles, and under mammals there's felines, canines, and it's easier for them to just inherit the methods exactly, right? And some of them even does these methods exactly the same way. Oh, I roar. Oh, okay, yeah, I also roar. But sometimes they roar differently, right? But sometimes some of them have the same exact, let's say they run at the same pace or something like that, right? Then in that case, notice for my get money method, right? I didn't even have to write it again. I just straight up didn't even have to write it. It's already written for me. I don't do it any different, and then I'm good. Let's say if it was an interface, right? Like let's say I had an interface like, I don't know, like get moneyable. Okay. Let's say there's an interface called get moneyable, and then it has some sort of method that's like exactly like this, like get aid. And let's say I wrote it like that, and then get rid of the public part, I don't need it, and then put a comma right here. So let's say I made an interface like this, and then aided student implements it. Then I would still have to write it all over again, but that's because it's an interface, right? We have to rewrite it over and over and over and over. And so that's where inheritance is a lot more handy, because you don't have to rewrite code that behaves exactly the same. And there's also this super, right? Like, what if they're exactly like their parent, just a little bit different? Like, okay, I'm gonna pass over all the similar parts to my parent, and then I'll handle all the new stuff. And over here, I know my parent can do this part, but I can just do this little bit of an extra thing. Actually, what I think you could do is you could say super dot. Actually, no, never mind. Never mind. I made a mistake. Anyways, uh, basically the point is, if you have similarities to your parents, or like if the models of your class has similarities between each other, and one of them encompasses all of the other ones, then it's just plainly a lot better to just let them have a hierarchy, inheritance hierarchy, because that way you reuse your code, and then you don't have to go around switching to classes back and forth one at a time when you're writing like 50 different classes that almost do the same thing. Now, the reason why we still need, so that, if I say it like that, right, like it sounds like interfaces are kind of useless. It's like, oh, inheritance is basically interfaces but better. But do you think you can come up with a reason why interfaces are still good, Yan?
So keep the project like that.
Okay.
So notice that shape is an interface, right? And all these classes, ellipse, line, pictures, color, rectangle, text, canvas. So all of these inherit shape. I think color is not a part of it, right? Is it color? Yeah, color is not a part of it, but notice that ellipse, canvas, text, rectangle, picture, line, all inherit. All influence shape. And can you open shape real quick? And you know that shape get X, get Y, get width, get height in paint, right? So you can go ahead and close it. And if you think it this way, rectangle is different from a picture, right? And ellipse is also different from a rectangle. So all of these, they have some kind of characteristic that connect them together, but they are not the same object. The things that connect them together are get X, get Y, with height, and paint shape, right? But other than that, when you find the error of those, they are not the same, or in the volume in this case. But when they influence shape, these unconnected objects with similarities in get X, get Y, they are able to connect together. So it allows you so this, in this case, the shape interface allows you to group multiple different class objects together as a big unit. So, and these classes, in exchange for implementing shape, they have to and must have to implement the bodies of the methods that they receive from shape. So, and the body part of these get X, get Y can vary, depends on each object. And also this trade-off is different from inheritance, is that each of these classes can implement as many as interface as they want to. But for inheritance, you can only instance one other class. Yeah, so that is the trade-off between inheritance and interface. You might get more flexible with interface in terms of methods, like what methods you want and what methods you don't want. But for interface, you can implement as many interfaces as you want to make that class more fuller, make the class fuller.
All right, so we have 5 minutes left. So do you just want to open it up to Q&A again?
Yeah.
All right. So
So
you go ahead then.
yes. So the question is, do we need to override Java full override? And I would say yes. It's a part of the Javadoc notation, so you do need to say override somewhere.
So whenever we're overriding a method, so I'll say override. I could write it like that. And wait,
You had to do the asterisk, asterisk.
what was it?
Just do like common Javadoc.
Oh,
Yeah, and I think override should like popped up or something.
okay. Well, it's different because I use like IntelliJ, so it does a lot of stuff automatically. But normally I would have to just put in this, and then that would work. But I guess BlueJ is different. Anyways, the point is, well, Yen says it is mandatory if you want to do it that way. But to be more precise, if let's say if you're asking if it's possible to compile the code and still have it override it without having to write override,
Still work.
it'll still work, yes, but it's not a good habit to make. If you're writing a method and you intend for it to override the other method, then you should be putting in that tag to make sure that you wrote it exactly the way they wrote it, just with a different implementation. That's what you should be doing.
Yeah, it's a good technique, but you don't have to. So we're open for Q&A for the next few minutes, but I just want to remind you again that next week, Mark, are you having a session on Monday, December 10?
Oh, so actually, work is going to be closed by then. So I'm going to be actually moving my my December 10 session to tomorrow, and I know it's really last minute, but I am trying to announce it on Piazza, and I'm trying to get everyone to uh, to see that. So it will be tomorrow. I will be having a final review tomorrow. So if you can, I suggest that you show up as if possible. Honestly, yeah.
Yeah, so next week will also be the last week of sessions for me, Tuesday and Wednesday. So Tuesday will still be the same from 4 to 5, 602 P connections. And Wednesday, 3 to 4, 601 IP connections. So those will, well, for mine, I will purely focus on final review, and which I will also review on inheritance because it will be for sure on the final exam. And just to review what topics that will be back on the final exam day. So if you might or might not forget scanner, it will be back for sure. And other things such as the graphics package, string class, array list, 2D array, interface, and inheritance. So those are a few topics that I can think of right now, but I think it pretty much cover all.
Mm-hmm.
So for string, just remember what methods we really went over, like replace, substring, length,
Mm-hmm.
uppercase or lowercase, something like that.
Yep.
Something that we learned before.
Yeah, and I would actually go ahead and watch the 2 previous episodes before this episode of Virtual SI, because they still cover basically something that's going to show up on the final anyways. It's very likely like it will show up not exactly the same, but some element of it is going to be reused for sure. All right.
Yeah. So that is all for today. Yeah, next week we just will be doing purely review for finals. So do you have anything to add, Matt, or?
I think that's all I have to say.
Yeah. So if there is not anything else, this is it. Thank you guys for tuning in.
Yeah. Thank you for showing up. I hope you have a good weekend. I'll see anyone who goes to my session on Monday, and I'll see you all in class Tuesday.
Yeah.
Thank you for showing.
Bye, guys.